All right, we're about to go on an incredible journey. Not into outer space, but deep, deep inside our very own planet. We're going to uncover what's really going on, miles and miles beneath our feet, as we explore the inside of our Earth. So let me ask you, what is under your feet right now? It sounds like a simple question, doesn't it? But the answer? Well, it's anything but simple. Because, our planet is way more complex than just a big old ball of solid rock. The best way to wrap your head around this whole thing is to picture the Earth as a giant onion. Seriously, it's got all these different, distinct layers, one nestled right inside the other, and each one is totally unique. So where do we start our journey?
Well, right at the top, of course. We're going to begin with the layer we're all standing on right now. Let's, literally, scratch the surface and check out the Earth's surprisingly thin outer shell.
So this outer layer, it's called the crust, and it actually comes in two different flavors, if you will. You've got the continental crust, that's the land we live on, and it's pretty thick, about 35 kilometers deep. Then there's the oceanic crust, under the sea, which is way thinner, only about 5 kilometers. And get this, they're not even made of the same stuff. The continental crust is mostly made of two things, silica and alumina. Geologists came up with a pretty clever and handy name for it, SiAl. See what they did there? Si for silica, Al for alumina. Easy enough to remember, right? And it's the same kind of deal for the oceanic crust. Its main ingredients are silica and magnesium. So, you guessed it, they call that SiMa. So just remember, you've got the thicker Sial making up the land, and the thinner SiMa under all the oceans. Okay, now check this out. To really put this all in perspective, the deepest mine that humans have ever dug is only about 4 kilometers deep. 4, when the crust itself can be 35 kilometers thick. I mean, that's nothing. We have, and I mean this literally, barely scratched the surface of our own planet.
All right, buckle up. We're leaving that tiny crust behind, and we're heading down, way down. Our journey to the core is going to take us plunging through this enormous layer called the mantle, right into the very heart of the planet.
And wow, just look at these numbers. This shows you how huge these other layers are. The crust, everything we know, our entire world, is just 1% of the Earth's volume. 1%. The mantle, a whopping 84%. It just blows my mind. And the core makes up the other 15. So, right under that thin crust is that giant layer, the mantle. And when I say giant, I mean it. We're talking 2,900 kilometers thick. It's absolutely massive. You can really think of it as the planet's huge, hidden engine room. And then finally, at the very, very center, you hit the core. It has a radius of about 3,500 kilometers. But the real story here, well, it's the conditions. It's almost impossible to imagine. We're talking about mind-blowing heat and pressure that would crush anything in an instant. So what in the world is this crazy core made of? Mostly super heavy metals. And yep, just like the crust, there's another handy term for it, knife. That's Ni for nickel and Fe, which stands for ferrous. Iron. This super dense metallic ball is what's really at the center of it all. Okay, let's pull ourselves back up from that fiery core for a minute and head back to the surface, back to the crust. We know about the layers now, but what is that crust actually made of? Well, it's time to talk about the fundamental building blocks of our planet, rocks. Basically, any rock you could possibly pick up anywhere on Earth fits into one of 3 main groups, or families: igneous, sedimentary, and metamorphic. And each one has a totally different and fascinating origin story. First up, we've got igneous rocks. A good way to remember this is to think ignite, like fire. That's because these rocks are born from super hot molten magma. Now, when that magma cools down fast on the surface, maybe from a volcano, it forms a rock like basalt. But when it cools down super slowly deep inside the Earth, it forms an intrusive rock, like the granite you see in kitchen countertops. Next up are sedimentary rocks. Think of these as a kind of planetary layer cake. They're made from tiny little bits and pieces, or sediments, from other rocks that get broken down and washed away. Over millions of years, these layers get pressed together and harden. And this is super cool. It's why they're the only kind of rock where you can find fossils trapped inside. Sandstone is a perfect example. And last but not least, metamorphic rocks. The name literally means to change form, and that's exactly what happens. You take an igneous or sedimentary rock, put it under some insane heat and pressure deep inside the earth, and it completely transforms into something new. So, plain old clay gets baked into slate, and limestone gets squeezed until it becomes that beautiful marble we all know. But here's the kicker. These three rock types, they aren't totally separate things. Nope, they are all connected in this amazing, never-ending process of change. It's called the rock cycle. Think about it like this. It all starts with magma, right? That cools and hardens into an igneous rock. Then, over a long time, that rock gets weathered and broken down into little bits, sediments. Those sediments get squished together to become sedimentary rock. If that rock gets buried deep enough, the heat and pressure cooks it into a metamorphic rock. And if it gets even hotter, it melts right back into magma. And the whole thing starts all over again. It's like the ultimate recycling program for a planet.
So, okay, cool layers, cool rocks, but why does any of this matter to you and me? Well, it matters a lot because we use these rocks and the minerals inside them every single day. Let's connect the dots and see how we use the Earth from way back in history to right this very second.
I mean, just look around you. The famous Red Fort, it's built from red sandstone, a sedimentary rock. The incredible Taj Mahal, that's made of brilliant white marble, a metamorphic rock. But it goes so much deeper than that. The fuels that power our world, coal, oil, natural gas, it all comes from the Earth. The iron, the aluminum, the gold that builds our entire industrial world, even stuff we use in medicine and fertilizers, it all starts right here in the Earth's crust. So, the next time you're out for a walk and you just pick up a rock, stop and think about it for a second. That simple little stone holds an unbelievable story. It could have been fiery magma, it could have been part of a massive mountain, or it could have been at the bottom of an ancient ocean. Every single stone you see is a tiny piece of a massive 6,000-kilometer journey. It really makes you wonder, what are you going to see differently next time you look down?